Hi everyone, welcome back to my YouTube channel. This is Project Explained, and I'm your host Davis. Now, today we are going to continue with the bore drilling series. And before we start, can you guys remember to subscribe, like, and comment. Now, from episode 1 in the bore drilling series, we did survey. Episode 2, we did bore drilling after test pumping and water quality analysis. Now the contractor or your driller needs to give you a document called oil compression record, and this is a standard document from Water Resource Authority. It's a form number 004, and I'm going to take you through of how it looks like and how you need to interpret yours. So let's get into it. Now from this page, you can see this is now how a bore compression record looks like. And as I told you, it's form 004. And in this document, there are usually other attachments that do follow. And you actually have the actual oil compression record, test pumping analysis, your bore sketch, and your water quality analysis. And you're going to go through them in this. So this is a full and complete bore compression record. Now, here, as you can see, it's form 004, and the catchment area is Athi. So whatever your catchment area in Kenya is, it will be written here. And there will be a Walma ID and a file number. Then this is the address of Water Resource Authority. This is their logo, and this is the Water Resource Management Authority. So this is bore compression record. Now, after this, okay, so I was here. So here you will see your bore number. And this number, usually get it after this bore compression record has been filled and signed and submitted to the Ministry of Water. That's when you get a special C number. And next, you'll get your bore name. This will be the client's name. And the formation will be indicated there. If it's a basement, it will be written as basement. If it's volcanic, it will be volcanic as this one. Then you go to particulars of the applicant, and this now comes to the owner who is drilling, who is applying for drilling a borehole, and or who the borehole has been drilled for. So the full name of the applicant will be there and is written in block letters. Then you'll have the category of applicant. It is individual, but if you are applying for an institution, you will indicate the institution, company, or association. And then you'll have an ID for individual, or a certificate of incorporation or a registration of groups of companies. That is, if you're dealing with an institution or a company. Then you'll have a PIN number. Then you'll go to the physical address where the borehole is to be drilled, and this is the aerial number, the exact land that the borehole will be drilled. Then the village or the ward, the sublocation, the location, the division, the district, all that you will fill in as per the area. Then you'll go to the contact and address of the applicant. This now you'll have the applicants or the borehole owners information. This is the address, the box number, the town, the postal code, the telephone, and the email. Then you'll go now to the particulars of the contractor. This is where now the contractor that has drilled a borehole for you will fill in his information, the address, the telephone, the license number, and the gazette notice that he was given. The drilling supervisor will also be indicated there, and the type and make of drilling rig that was used. So if your borehole was drilled using a max drill, they will indicate that it's a max drill or a speedster. So, and their email contacts. Then there'll be this part of the intent use of water. You'll indicate there are options. Is it for public, irrigation, industrial, domestics, or anything? So as for this one, because this sample was for a domestic customer, so he had requested for domestic and irrigation. So depending on your application, that will be filled there. Then you go now to the particulars of the actual borehole. Now, type of borehole. Was it drilled, bored, or jetted? So this was a drilled borehole. Then you'll have the borehole construction, and you'll indicate the date. This is now from the driller's log, and you'll get the date that it was started, the date the drilling was completed, and the date they demobilized from the site. And they will also indicate the total depth measured in meters. If there was any backfill, it will be indicated, but in this one there was no backfill. Then the hole diameter, this is 2. Okay, so you can see the hole diameter. This is the piloting hole, which was around 2.5 meters. This is where the surface casing is usually installed. This was drilled 254 millimeters is 10 inch. Then from 2.5 meters, it was drilled by 8.5, which is 2 or 3 mm. So from 2.5 to 240 meters, this bore was drilled by 2.5. Then that is page 1. Then you go to page 2. Now page 2, you'll now get to the casings, the way they were installed, and there is the plain ones and the slotted ones. So from the sketch, I'll show you how you read it, but like from this one, this is the diameter. Diameter is 152 millimeters. This means it's a 6 inch. So from 0 to 147, it was a plain casing. Then it is indicated as the total length of meters, which is 147 meters. Then from 153 to 159, it was a plain casing, which is 6 meters. Then 183, like that. That's how it's done, but I'll show you in the sketch. Then you go to the slotted. The slots started at 147 to 153. If you note here, from 147, sorry, let me show you. This is 0 to 147, then 153 to 1. So you see there's a gap in between 147 and 153. So because this plain casing started at 153 to 159, that's why it's indicated from 147 to 153. That difference is 6 meters. That's why a 6-inch casing was installed. But I'll show you in the sketch. So they follow like that. This is just the tabulation. Then you go to the gravel pack. There's the size of the grain. The gravel pack I showed you is a filter component that is installed in between the drill diameter and the cased diameter, in between there. So we'll have 2.4 millimeters. That is the thickness of the gravel grains, and should be rounded well. That's why it's indicated. The roundness should be good. Then the volume inserted in the annular space in meter cubed was 9 cubic. That was determined on site from the driller's log. Then if there was an open hole, you indicate there. Then the water strikes. This is where the aquifers were striked. So this borehole 160 to 180. Then the main aquifer was striked at 210 to 220, and the water rest level, which is the static water level, it was 149.65. This you'll also see it in the test pumping results. So here, other aquifer remarks, you write here. Then there'll also be the yield. This is the static water level again, the same 149.64, it's indicated there. Pumping water level, this is the last reading of test pumping, 223.45. All these data you're going to confirm in the test pumping. And the discharge, this is a 266.72 liters per minute, but in the test pumping we'll see it in meter cubed per hour. So what you just do is divide by 16.67 this one, and you'll get the meter cubed per hour. Then test pumping was done for how many hours? It is indicated 24 hours. Then the expected production discharge. Then water pump set, where was the pump set, is indicated there as 228 meters. Then you go to page 3, and this is now where you get your driller's test pumping data. And from this page now you're able to say test 1, because mostly we usually do test 1. Date of test is indicated there, start to stop. Then the bore depth is indicated 240 meters, static water level. The pump that was used, this was used as 1733. Depending on the size of the pump that the driller has used, will be indicated there. Then the pump, the depth of the pump intake 228, same as we saw here, 228. So we go to the discharge in liters, 266.72, and I told you this you can divide by 16.67 to get in meter cubed. Then pumping water level, this is the last reading of test pumping, it's indicated there. After pumping continuous 24 hours. Then now you observe the recovery water level. So this bore recovered after 5 minutes. The water level moved from the pumping water level, which was 223. After 5 minutes, it came back to 168.60. Then after 20 minutes, it was at 159.75. This is now, it's coming up. After 60 minutes, 153.15. So this basically is all the data that is in the test pumping sheets. Now, then you go to water quality analysis. In here, usually have the sediment, the color, the odor, and the specific conductivity of water. So in this point, you're asked, or your driller or your contractor will indicate the sample was collected, yes, collected what time, indicated there, and what date. Then was there sediments according to this bowl was nil, but if other bowl, you can indicate the taste, the color, all these parameters. You'll get them in the water quality analysis, and I'll show you now. Then there is the remarks in drilling. Were there any difficulties? The gravel pack details. So you indicate there the bowl was completed as specified. If there were challenges, if there were backfill, if anything happened, you need to indicate here. Then you go same page. Then you'll have the signature of your drilling supervisor and your drilling contractor and the date. So this is done by the contractor. Then you go to the fourth page. This is where now you get the logs. Now, as I told you when we were episode 2, there was something I told you called a sample rack or a sample box. This is where now the soil is recorded in intervals. So you see from 0 to 2 meters, they recorded dry topsoil going like that. So this is basically the logs of the specific borehole, and these do vary from area to area. So if you are drilling at a different area, this was in Nairobi, this is how they got the logs. So read them like that. Then we go to, now this sketch, now it is attached, I'll show you. Now this is for the official use. This is where the WARMA people, the Water Resource Authority people, will now fill in. Now at this point, now the first part of the BCR is complete, and if you have noticed this is where all the data of the bowl, from drilling, test pumping, casing, gravel, everything is indicated. But now I now go to show you now what we were talking about now. So we start with the test pumping, and this is a sample of our test pumping data sheet. So you see it's written constant discharge and test pumping for 24 hours. So here you indicate the date, the client's name, the location, the depth of the pump, the static water level. Remember it was 149.65. Then the power source, mostly usually use generators. The pump that was used to test is 1733. Then the testing contractor will be written there, the name of the contractor, the driller, the bowl number. Then the pump set depth 228, remember we saw there, the pumping water level, and the discharge. That's why I told you in test pumping we get them into meter cubed per hour. Then the GL, this is the datum, this is the distance in between the ground level and the top part of the casing. It was 0.3 meters, that's like a foot. Then now, so they started at 7, and you see they record in minutes going. See, this was the static water level. Then they started pumping, and at this point the gate valve was half opened, and the water that was coming out was brownish in color. So they will monitor these up to 24 hours, and they'll be recording depth as it goes down. And this is a drawdown. The drawdown is the difference from the static water level to the pumping water level. So the drawdown will go increasing like that until you get to the last reading of the pumping water level, and you'll always be recording you'll be recording the discharge in meter cube per hour. And the mode of test in this, it is time against a 20-liter bucket. So you set a stopwatch and record how long or how many seconds it fills a 20-liter bucket. And the figure you divide by 72 and get the yield of the borehole. So as it is there, right there, as they were going down, the hills were going decreasing because it started. The water is also going clearing. You see, at this point, the water has cleared. This is now clear water at around an hour. So they record like that until they hit the 24th hour, which is 1440 minutes. And the recorded yield was 16 meter cube per hour. The water was clear, and the total drawdown of the borehole was 23.20 meters. So you can minus the 223 minus the 149.65. You should get 73.8 meter, which is the total drawdown of that borehole. Then the test was witnessed by who? The contractor will sign there. So at that point, you have the test pumping. Then you go to recovery. What you do the recovery is called constant rate recovery test. This is now observing water coming from the pumping water level to how far it will come up. So the same information will be indicated there, only this will change. It's the recovery water level. This will replace the pumping water level. So it is 153.1. Now, see, this is where they start, 223.45. This should be our pumping water level. You see, 223. This is the last reading after test pumping. So that's where they start observing. So they observe as the water comes up the borehole, recording the drawdown. It's not the drawdown, recording how the residual drawdown now is coming up, which is here. So you come, so at an hour, this bowl had recovered to 153.15. So that is test pumping. So you've done the test pumping and recovery. And if you have noted, all this information was in the bowl compression record. Then from here, we go to the sketch now itself. Remember in the first page, we saw the bowl was drilled 203 mm, and this is 8.5 inches, and usually have the name of the customer here. And this is not drawn to scale, this is a sketch. So this is a pictorial view of a borehole, and as you can see, this is the ground surface, and this is the bowl cap here up. Then we have this point that the bowl was plugged. So it depends with what depth, so it will be indicated there. Then remember, when you are at page 2, you saw from 0 to 147 was a plain casing. Now this is what it means. 0 to 147 is a plain casing, then 147 to 143 is a slotted casing. These ones that you can see that have slots, these are slotted casings, and in between the drilled diameter, which is 203 mm, and the 150. So after looking at the gravel pack, that is how the pictorial view looks like. Then you go down and you'll see, let's reduce this so that you can see the full page. Now this is how it looks. So this is the gravel pack. This is where it is indicated the screen casing 6 mm. These are the screens, and this is the planes. So it's indicated there, the planes, and that's how they have followed each other up to 240 meters, and the yield is indicated there. So that's your bowl sketch. Then we go to the water quality analysis. Now this quality analysis depends on the lab that we've tested, and this is a sample. This is not exactly for this borehole. So usually get the logo of the company, but it should be regulated by the KENAS. This is the Kenya accredited accreditation services for testing water qualities as per basic drinking water analysis of World Health Organization. So in that, depending on the company that has tested your water or the lab, it may come differently, but this is just a sample. So this is a sample of a water quality analysis that has a customer name, the address, the site name, the contact person in the company, and what was the water for. It was water used for domestic. Then there'll be comments, the conditions, everything. If you are testing this water for bacteriological analysis, it would look different because you test for E. coli and other things. Now, this water was for, the source of the water was the borehole. Then now in this water quality analysis, you can see anything that is it's in red, it's above. that means it is above the required guide low or guide high. So like the pH, you see the guide high is 8.4, and the guide low is the guide high is 8.5 and the guide low is 6.4. But the results of this borehole, the pH was 8.87, so it is higher. You check at the electrical conductivity. The guide high is 1.8, but the result is 1.24, so it's within. Then we go to this sodium. The guide high is should be below 200. This is parts per million, but the result is 282. You can check here, it's 282, so that's high. Then you come to bicarbonates. The guide high should be less than 255, but our results is 507 parts per million. And this other one is fluoride. Fluoride also has a guide high of maximum of 1.5 parts per million, but at this point this was 8.87. So this is what you get, and they usually get comments here. They'll advise you on the kind of treatment you need to do and the recommendation. So this differs from the type of lab you've taken your water, or the driller that drill for you has taken your water. So as at this point now, this is a complete ball compression record. What now remains is need to be signed and stamped and submitted to the Ministry of Water, and a copy to Arma, and to the client also a copy with a serial number. And this document will help you now in applying for your water use, which is a abstraction permit. That is after pump installation. And that's it for the bowl compression record. Any questions, I'll welcome in the comment section. And I really appreciate the support, and I'll remind you to subscribe and support the channel, yeah, for more content. And as for now, we say thank you. Ciao. Love you guys.